Hello, everyone. I'm Anastasia Marchinkova, and today I'm really excited to have two amazing guests to talk about the Airbus BMW Quantum Computing Challenge. So we have Elvira Shishenina from the BMW Group and Jasper Krauser from Airbus. Thank you so much for being here.
Thanks a lot, Anastasia, for inviting us. I'm personally a very big fan of yours, so very excited to share the insights on our challenge.
Thank you so much. So, Elvira, can you kick us off and tell us a little bit about yourself and your journey in quantum technologies?
Yeah, with pleasure. I'm leading a quantum team doing the research and applications in quantum computing in BMW Group Central Invention. For instance, it's a very small team, but we have quite few experts and are already able to do some first steps in this big quantum journey regarding the future mobility applications. On the background, I'm a mathematician with a quite small transition towards the development of a quantum software first. And right now we are a little bit mature, so we are going deeper and deeper into the quantum science regarding the different application domains, including the material science, the optimization, AI and generative modeling, as well as solving complex multi-physics problems. Yes, we had this already, I think, discussion around what motivated us to partner with Airbus is just because I think everyone knows we have pretty similar challenges, but we don't share the same customers, and that's why we're super happy and comfortable to work together. Especially, we do share the same passion to the emerging technologies, and that's why I think this is a big beginning of a longer story, I think. And yeah, very very excited to see what it gives.
Yeah, definitely. This is not the first quantum challenge out there. So it's been exciting to see more companies getting into the space and partnering on that as well. So, Jasper, can you give your background as well?
Thank you very much for this opportunity. So I'm also from a background, I'm a quantum physicist. I did my PhD and then my postdoc in this field, in the fundamental quantum physics side. And I always wanted then to make it useful, to bring some value to it. And that's why I joined Airbus. Today at Airbus, I'm the coordinator for all of our quantum activities in Airbus Group. So what we're doing in commercial aircraft, but also in helicopters and in the domain of defense and space. And so I'm taking care of all our activities in computing and communication and sensing. And yeah, I'm really excited that we have this opportunity to work in this realm also with BMW. So as Elvira was saying, we have similar challenges, still in a very early stage. But the great thing is for the aerospace domain, there is so much potential in quantum, and I think this is motivating, it's motivating me and also our team every day to work on this great topic.
And you all both mentioned these exciting challenges and you get to work together. So, can you tell me why are we today so excited about quantum and why are you particularly into these quantum challenges?
Well, maybe I start from the aerospace perspective. So we see, even though quantum technologies are in a very early stage, we see a lot of potential at the very heart of our portfolio. So in a way, how we design aircraft and how we operate, how we fly them. And so our ambition is to be an early adopter of quantum technologies, and this is something we have to start early to prepare for it. I think the applications in aerospace, and that's maybe something which is quite specific also to our industry, is in quantum computing, definitely, because we are compute hungry. We need a lot of computational power already today. We will need more in the future. But it's beyond that. We are also very interested in quantum communication, so harnessing cyber security cryptography, for example, and also quantum sensors. So our products are filled with a lot of different types of sensors, and there's a lot of opportunities from quantum technologies also to improve that. So the range of applications is really, really broad. It's also a challenge because we have to focus. We have to understand which are really the most promising applications. But this also makes it so exciting to work in this field.
I fully agree with Jasper. I think we have similar story here. Just to say is that There are obviously some problems or challenges in BMW, same as in Airbus, that we want to solve faster, more efficient, better, more accurate, more sustainable, in a more sustainable way. And sometimes there are limits of classical technology to approach that. And that's why we need to consider some maybe different computational paradigms. It can be AI, it can be like people are digging into the neuromorphic computing or thermodynamic computing or even quantum computing. And this is, let's say, our part to figure out if the challenges that we don't know to solve as good as we would love to are, first of all, matching to the quantum computing paradigm, and if we can expect in the future some advantages coming from that. But if not, the second, I would say, biggest purpose is actually to maybe discover those new applications that, for instance, with our narrowed classical vision, we don't consider yet, but that could make total sense from the quantum computing perspective, and that could bring a lot of value to our business applications. And speaking about challenge, this is not the first edition for us, for BMW, and neither for Airbus, who was the pioneer in this field. But this is for the first time that we introduced this, let's say, new challenge, which we call the Golden Up. Is basically we ask the community and the ecosystem to come from inverse perspective, not from the challenge to solution, but actually from the solution, from the quantum technology perspective, and propose to us some native applications that could revolutionize in the future the mobility sector for both automotive and aerospace.
Yeah, so both of you all hinted a little bit about the game-changing technologies, so I want to dive a little bit deeper into that. So what particular areas makes quantum technology a game changer in your industries?
Well, first of all, whatever can match, let's say, the behavior of, let's say, quantum systems can be probably considered as something very native, where we could expect probably the most value coming from the quantum computers, right? The first thing coming in mind is, of course, materials research. And this is something that people or experts believe to be the first area where we could see the practical quantum advantage. There are some areas in finance, in optimization, that can also kind of reproduce this type of behavior. We could already observe some steps and atoms to solve those problems on the NISQ devices with some propositions towards some tolerant approaches. Of course, it's a huge journey. We need to be patient, especially on the industry side, because we usually have this tendency, to bring the success closer than it is. So we need to give a time to technology to mature, as well as do our job on the applications and software side, and to prepare algorithms and problems. But there is also another, let's say, stressful point for us, is that even practical advantage is not really sufficient for us, because between the practical quantum advantage on some, let's say, small fundamental problems that for chemistry, for instance, we can achieve on the very, very small systems, is not something that could represent the business value or business relevance for us. If we're speaking about the applications in batteries or hydrogen fuel cells that we explore, for example, together with Airbus as well, for one of the collaborations, the Quantum, this is not the sizes that we would like to tackle, actually. For some business relevance, we would have to still do some job after achieving the quantum impact or the practical quantum advantage, towards scaling up the approaches, as well as the hardware providers will have to do some job towards scaling up the machines. But yeah, we keep optimistic. I think the progress is good. We do our job, we discover, and very excited to the future.
And maybe what I could add is maybe from the aerospace perspective, if you look a bit more at the global picture, then our industry is extremely relying on computational power. So we are operating in our industries, and I think the same is true also in BMW, very powerful high-performance computing systems. In Airbus, we have two major ones. One is in Hamburg, the other one is in Toulouse. And they are these traditional aerospace tasks, like structural modeling, aerodynamic simulations or computational fluid dynamics or acoustic simulations, and so they're extremely computationally expensive. But on the other side, the aerospace industry is also turning more and more into the data rich or even data dependent industry. So we see that our products, let's say our satellites, they produce more and more data. We have much more sensors on board of our aircraft, which provide data, and all of this data needs to be processed, needs to be analyzed, and also there you need computational power. And so that's why we already know, like when we think about the future, we will need more in the future, but there's of course some limits, some economic limits. It's also the question of the energy consumptions of those systems, which doesn't make sense at a certain level anymore. So we need to explore new solutions. And this is really, I think, at the very heart of the mobility sector. And quantum is one of those options which is very promising in this field. So at Airbus, we are structuring our applications along 4 different application areas. Elvira mentioned already some of them, like the chemistry related problems. So here we have worked, we have done some very great work together on, for example, modeling chemistry and fuel cells, which is relevant for both of our industries. And we are also looking into optimization problems. There's quite strong focus on operations. So how you fly an aircraft, how you optimize trajectories, for example, to save some fuel. We are looking also in quantum machine learning, focusing on data processing, data analysis. And then for us, it's really at the very heart of our industrial sector to look into what we call quantum solvers. We see potential to use quantum computers in solving equations to improve, for example, aerodynamic modeling. And this could lead in the end maybe to the capability to design more efficient aircraft. So that's why the field of quantum computing is very broad. It's still very early, and I fully share the view what Elvira was already mentioning, that we need a very long breath in this development. So we need to make sure that we are aware of all the difficulties. But I think the potential which is behind is really worth also investing this effort.
Yeah, definitely. It's such a broad field, right? I was recently talking to some folks about, how do we teach computer scientists the quantum side, and how much do they actually need to know, and how do we kind of bring them into this quantum space, because there's not enough people studying the field that when we get these large scale quantum computers to actually, run them all. So it's a very interesting time, because it feels almost like the 70s of computing, and we get to be on the forefront of that. But yeah, there's so much to do. There's hardware, there's software, there's everything in between that we really want to get going on the quantum space. So you've mentioned this a little bit with some of the experiments you've done. So which quantum technologies, and by that I mean less applications, but more maybe hardware or software that you're looking at, are you currently prioritizing in your industry?
That's a tricky question because it's a huge race right now. No one knows who will win in the end. Probably it will be not one, but many winners, because each architecture has its pros and cons, and there are certainly some of the applications that much better one than another one, right? It's hard to say right now. On the industrial side, I would say we have much less pressure than the quantum hardware providers have. Because we are able to choose and we are able to work with many at the same time. And that's what we do right now. We try to explore by doing, keeping our hands dirty, and trying to kind of understand from the very inside the advantages of using each specific technology. It's also a question of, the hardware software co-design as well, right? Because sometimes we are thinking that some specific applications would require some specific approaches and algorithms, and maybe some specific types of gates and middleware to implement in order to kind of make it or perform it in the most efficient way. And that's why it's also nice to keep in touch with the providers who have quite agile and flexible state of mind, let's say, in order to maybe adapt some of our needs or help us to find this way towards the most efficient implementations and most efficient development. And yeah, to not repeat again is this example of the golden app from the challenge. There we actually just relying 100% on the solution developers and quantum providers. So maybe we do have a technology which is not perfect for all those cited applications that Jasper just mentioned, but there is something that we can do perfectly, and that is not yet explored within the mobility sector or industry sector in general, and that could make total sense and bring a lot of value. Why not? So we are quite open with that. We work together with our business units to understand their needs. Usually the question they ask them is like, if you remove all the restrictions, what in the ideal world would you like to do, and see how we can come up from that perspective. As well as we have quite strong teams in BMW of technology scouts who are helping to us identify those emerging technologies in the very early stage, and not necessarily working specifically with one or another, but figure out how to merge them together. And we'll continue to bring people into our small quantum yet team in order to enhance this process and keep the know-how inside BMW.
Yeah, maybe to add on that. So I think there are always two different sides. One is what is the current level of maturity of the quantum technologies, and then also where's like the big impact, and where's the push, the technology push. Pull. So what I think is important is that when we work in, let's say, a research team in a company, that we connect to the end users, to the business units. And this is actually something great. In Airbus, we have like a great amount of, a big amount of really great engineers specialized in their fields. They're the super experts in their specific use case. And they show a lot of interest in quantum technologies. Can you give you one example? We have one of our competence centers about flight physics, so how you design, how you operate, how you fly an aircraft. And they have really teams who start looking into how can quantum computing help them. And this is how we collaborate inside the companies. We bring in the upstream part with the business pool in the end. And I think this is really where you in the end can set the priorities. I would also say it's not so much of only setting priority, but it's also to understand the timeline behind. Because, for example, some quantum technologies like quantum sensors and quantum communication devices, they are technically more mature compared, for example, to quantum computing. And if we have this level of maturity, we can now do the next step and integrate those devices into our products. And this is something we should really not underestimate the effort behind. There's a lot of work which needs to be done if you want to fly a quantum sensor. It's not just that you build one and you put it in an aircraft. You need to do a lot of engineering around, and this is where we are focusing on a lot when it comes to more application oriented to the real application. But I wouldn't say that, for example, quantum computing, it's still very early, but I wouldn't say this means it's of a low priority. It's just we are here in a different timeline, and we also have to make sure that we are ready as a company to use quantum computing when we have reached the right technical level.
You all have a lot of projects going on. So can you provide a few concrete examples, maybe one or two, where quantum technology has already shown promising results or potential?
Maybe to shout out the recent one that was published around the hydrogen fuel cells catalysts. Again, it's not a secret that people and experts are trying to explore the potential of quantum for materials research. It's not like the classical quantum computational chemistry is bad, because there are still some good, very approximate solutions that works for certain types of systems. But unfortunately, there are very bad systems, very strongly correlated materials there. The classical approximate large-scale solution doesn't work. And the exact one are inherently not improvable. So we have some hard limits, and that's why there is no choice but to go to the lab, synthesize those candidates of potentially good materials one by one, and see if it works or not. And this takes a lot of efforts. This takes a lot of hours. It's also questions of safety, sustainability, and many other points. I think one of the earliest applications for quantum, at least in the energy transition sector, was the electric batteries, lithium-ion batteries. Both BMW and Airbus released recently their hydrogen strategy. So we do have hydrogen-powered cars, and as Airbus projects on hydrogen-powered airplanes that Jasper could tell you a little bit more, but we were thinking that the hydrogen fuel cells is also the technology that has a lot of potential, which is a little bit right now underestimated by the community simply because there is a lot of energy loss while we bring in the hydrogen from, let's say, the initial production source through the storages and towards the fuel cells. And we wanted to see how just by identifying better or optimizing better the materials that we use for catalysts, we could improve this performance of fuel cells and reduce this energy loss. And when we started to dig deeper and communicate with our business units, they figured out that there are some reactions on a pretty fundamental level that are responsible for this performance. And because no one knows the mechanism, how exactly it happens, no one knows how to replace, for example, the current conventional materials that are based on platinum and some other noble materials, super expensive, with something cheaper, more sustainable, and that would provide with better performance. So we started with journey 3 years ago in 2021. First, BMW collaborated with Quantum in order to do the phase 1 modeling with a very small system and to try to reproduce some of the experimental results that we could find in the literature. And then we were happy to welcome Airbus in this collaboration because they could bring quite a lot of knowledges and know-how and expertise coming from the processes that happens in reality on the chemistry level. And basically, we could expand this collaboration to the phase 2 with some bigger and more realistic materials and merge all the potential of classical fragmentation and embedding techniques with quantum, highly precise quantum solvers in order to scale up the solutions that we developed in the previous phase and develop the workflow that could be reproducible with, let's say, better performance and accuracy once bigger machines are available. So this is what we're looking for right now at this stage. Again, no one claims the advantages, but there was some quite good hardware, quantum hardware results received after this research work. We continue to explore it and again build up on a roadmap and a workflow towards future business relevance in this field. So I think this is one of the maybe best examples that kind of unites BMW and Airbus as well and represents well the mobility sector. But yes, as Jasper said, we also have those applications or challenges related to the autonomous driving and generative modeling. This is quite tricky area because we don't really know where the advantage will come from regarding the quantum computing, but we want to explore and same as multiphysics, complex multiphysics simulations, including structure, aerodynamics, aeroacoustics, and our physical processes.
Thank you, Elvira. No, so I like very much your example, and maybe just to complement why this is so interesting for the aviation domain. So at Airbus, we really believe in the challenge to come to net zero in 2050. This is what Airbus is committed to. And if you want to fly such an aircraft, you have two ways how to use hydrogen. You can burn it, like you do with kerosene in a combustion engine, or you can use fuel cells. And this is why fuel cells are so important for us. And the fuel cells we will need, they are not fuel cells you can just buy as on the market as such. And that's why Airbus has found a joint venture an automotive specialist, Elring Klinger, which is developing a fuel cell stack for this hydrogen-powered aircraft. And this is associated with the challenges, of course. And one of the challenges is that they would really like to be able to understand to the best way possible the underlying mechanisms of the chemistry in fuel cells. And this is very difficult on classical computers, and here's exactly where this work is coming in and might provide really a significant advantage in the future. So it can basically accelerate the transition for decarbonization of aviation. Maybe I'm adding just another example, which is not in quantum computing, which is maybe a bit more concrete, but also really interesting. It's an application which personally I'm also really excited about. It's to use quantum sensors in satellites. A lot of work has been done to bring ultra-cold atoms as a sensor into space. There are many interesting things what you can do. This has been already, let's say, tested in on-ground applications. And the next big quest is how can we bring this into space? And Airbus is here very engaged. We are working in a large consortium as the industrial lead to integrate such a system on a satellite, bring it to space with the objective to measure environmental parameters from space. And here it's about measuring the gravity field of the Earth. So it's a very exciting applications. There's potential that you can measure once you have this in orbit, the gravity field of the Earth with a much higher precision than we can do today. And these are data which are very interesting, for example, for data scientists. This is what they use when they do climate modeling. So if once we have this capability, it will help us, for example, to improve our capabilities to model, to do climate change modeling. And so that's why I think it's a very nice example, because it's already kind of, so the path towards realization is clear, and the impact is really to improve, let's say, to improve our understanding of the world and to make our society better.
Yes, quantum sensing has kind of been overshadowed by the quantum computing hype, right? But yeah, there's a ton going on in the quantum sensing space that people don't talk about. There's the ultra cold atom lab on the ISS and doing very cool things, and people, are sometimes skeptical again of, why is quantum useful? And quantum, is in everything in the world, and quantum computing is just the next step there. I think the ultra cold atom lab on the ISS is the coldest place in the universe, right? Because we're building a Bose-Einstein condensate, not even on Earth, but in space, which makes it even easier. But there's definitely still skeptics in the quantum computing space. They say, well, you guys have been working on this for 10 years. It's always 10 years away. Why is it going to be relevant to my industry? We don't have quantum particles, or we don't care about materials, or are we really going to be able to scale the hardware beyond 1,000 qubits or 10,000 qubits? Or are we ever going to get the error correction low enough? What would you say to these skeptics?
There are still kind of some, well, the good thing is that quantum is not anymore in the discovery phase, right? So right now it's a pre-engineering problem, and we see constant progress on the hardware side. Yes, again, as any emerging technology, it needs time to mature. And it's up to us to kind of reduce the stress that we send to the quantum providers so they can do their job properly without, increasing the hype ways or whatever deficit of scientific communication around that. So we need to be, I think the progress is quite good. I mean, I just remember when I came to the field, and I was happy and excited to see hydrogen simulated with VQE with 5% error. For me, it was like a magic, right? Just to see that it works somehow. Right now, we do very complicated things with the accuracy is closer to desired chemical ones. We are still not yet at the level of the quantum advantage, but we're moving towards to that. And the same way we will move from the quantum advantage towards like business relevance and impact. We just need to kind of join the efforts. There are some evidences why for some specific applications it might work and it might work well at the first time for the super large scales, but even on the smaller scales, we have some problems or issues to solve, or maybe some single point calculations that could be used as an input for some bigger things where we will use classical technology at the first, or maybe again like use this quantum black box to improve something that is classically convenient yet. Let's see how it goes. The best we can do right now is to bet on the technology, on our efforts, join them, and to help the technology to progress and mature, bring in as much as possible insights from the real life use cases. And this is what we do have actually, thanks to our business units. So I'm sorry that I can't give you some concrete numbers. But I think no one is able to give that, or no one is able to give some prognosis. But being innovative companies, it's also a sort of responsibility, right? To drive the innovation and to motivate the ecosystem to contribute to the technology development. And this is, I think, what we do. With both challenges, we try to nudge this pure fundamental quantum technology into a little bit more practical sense and accelerate a little bit this transition.
Yeah, maybe I can also try to give an answer. It's not very easy, right? But I think in the community, you always have these both extremes. You have also some skepticism always, but also, for example, some hype, right? And I think it's kind of it's a normal thing for innovation that this happens, and there is always uncertainties. I mean, this is part of innovation, of the innovation process. And I think what it could help in this context is to try to think in analogies of other innovations which took place. So take the example of aviation, right? So you have the first flight of the Wright brothers in the beginning of the 20th century. And you have, let's say, the first commercial jet maybe half a century later, when you think in terms of development timelines. And here I would agree with Elvira. I'm quite sure we are not anymore at the Wright brother moment. I think we have passed that. But nobody knows where we are on this way. So, and and I think there we just need to be honest about it, that it might take longer, maybe significantly longer. I think what's always maybe also kind of makes it easier for the mobility sector that we think in very long timelines. So when we say we are bringing, so our ambition is to bring a hydrogen-powered aircraft into the market in 2035. This is for aviation like tomorrow already. So we really think long term. And that means, I mean, we are not relying on having a fault-tolerant quantum computer in the next 3 or 5 years. If it takes longer, it will take longer. We just have to make sure that when it's there, we are able to use it.
We usually thinking about like, what if I do and what are the risks, right? But if we turn it on from the different way, like what are the risks if I don't do, right? And this opens completely different perspectives, I think, not only for aviation, but for automotive and any other industrial sectors. I'm happy to see that there are a lot of automotive companies are involved in the quantum journey. And not because we are competitors and we have to be kind of a little bit more angry on each other or whatever, but just because it enhances the movement towards the mobility applications, which will potentially, create the momentum for automotive applications and the products that we will be able to produce in the future, the cars that we will be able to produce in the future. And again, when you see this, let's say, involvement, it also kind of gives a certain responsibility to think about, okay, what if I don't do it right now? So what happens when the technology finally comes and those people already have a know-how, they already have a certain IP, they already have certain workflows, so that they can already take this technology and use it, and not thinking on like how and what to do with that. So this is quite, again, difficult question. No one will give you numbers or prognoses in terms of how much time. But we're happy to at least profit this momentum that no one presses us to deliver quantum advantage tomorrow and the new quantum powered cars after tomorrow. So we just do our job and trying to do our best to motivate the ecosystem to help us.
Yeah, I really like the point that you all made earlier about this is now becoming more of an engineering challenge and not a fundamental physics challenge. But even then, historically, we've seen when lasers first were created, it was just like, oh, cool, it's this thing. Now lasers are in everything, right? So sometimes, you need to take the fundamental research. But again, as y'all mentioned, I think we're way past that. We are seeing advantage. We're seeing even simulators creating advantage. And in the meantime, I also really liked your point about the different hardware modalities, right? This is something really new that we've been seeing in the last couple of years. It used to be, this hardware is going to win completely. And now that we're seeing certain applications are better on certain types of hardware. And so over the years, I think we're going to see this more and more things play out. People are going to discover that superconducting or trapped ions are going to be better for certain types of problems. So very interesting space. So the next part of it is I want to dive a little bit more into the challenge itself. And I've been really impressed and happy to see companies that are not super secretive about what they're doing in quantum technologies. And you all have been doing this challenge for a while. So what inspired the initiation of this challenge and the previous quantum challenges you've been a part of? And what positive outcomes have you seen from running it?
Maybe the first challenge was quite successful. So the first inspiration was the success of previous editions, I guess. But for the previous editions, there are many positive, let's say, benefits. As first of all, again, we're trying to share with the ecosystem and with the engineers and scientists the real life problems and constraints. So it allows them to better understand the specific of the real world problems. So that they can easily transition from like the very fundamental theoretical space into something more concrete and valuable for real life. It also allows us to evaluate more or less the landscape of the players who are presented right now and the current state of the technology. We had a lot of subscriptions, a lot of motivation from the ecosystem from more than 50 countries all over the world, and we can't be more grateful to all those people who motivated themselves and took a part. And we feel that we actually contribute to the technology development just by motivating all those people to tackle the real life challenges, or at least to think about this transition from pure fundamental into something a little bit more applied. It also allows us to make a little bit of estimations on how technology progresses. So you could see that Airbus and BMW challenges, they both had not similar use cases, but at least similar areas of application, right? Optimization, machine learning, differential equations. So by kind of resubmitting the challenge over, let's say, a few years between each other, we're able to follow up on how technology actually progresses towards those applications, and if we're closer to something meaningful or even further than we were before because of some maybe discoveries in the meantime.
Yeah, we hope not. But I think I could jump in on that. When I think about our first challenge, then it was really, I think it was 5 years ago, right? So quite some time ago, the quantum community was in a much earlier stage. And the idea was really to see, okay, we are not, of course, a quantum computing company. We will also not develop into a quantum computing company, but we are extremely interested into what this technology can provide to us. And that's why the idea was really, okay, can we connect to the community? Can we increase the visibility of our specific needs, of our use cases? And can we leverage the potential of these many brilliant minds out there to think about how we can use quantum computing in this context? And this was actually really very early at the time. Nobody really knew, at least we were not aware of what aerospace and quantum computing could work. And I think this really accelerated this. We had similar experience, as Elvira was mentioning, like a great feedback from the community, global responses, high level submissions. And I think this was then indeed the motivation. Okay, we have such a good result, so much inspiration from that. We believe we had an impact, and we think also there was now 5 years later so much development in the community that it's really worth to think about a new edition. And we are super happy that we are doing this together with BMW, because we bring two industry leaders in their respective fields together, and we just join forces. And I think it's makes it much easier also for the community to approach this, because in the end, as Elvira was saying, many of our problems have similarities. And it's correct. We also bring in these use cases, so they are not anymore, let's say, a secret. But on the other side, we have seen in our last challenge that over the years, new groups have looked at our challenges. They have started to provide solutions. They have contacted us, and I think at this early stage, where I think it's fair to say we are pre-competitive for the end user perspective, this is what we need to do. So we need to collaborate, and we need to avoid to think in silos. And I hope that the second challenge will also provide this impact.
So let's talk a little bit more about this actual challenge. So it's the quantum mobility quest. And like you mentioned, there's a specific application area, or there's a few specific application areas in the challenge: smart coding, quantum powered logistics, quantum enhanced autonomy, and quantum solvers. So you're giving a more defined problem set there. But there's also the reverse track challenge, the golden app challenge. So I'd love to ask you about, what is this challenge about, and what are you looking for in these application areas?
This is a little bit of novelty that we brought this year, because there is this common opinion that most of the applications that in the end we will solve maybe with a quantum computer are not yet discovered. I think it was similar with the race of AI, right? So from the beginning, like, people just called it, okay, it's a matrix multiplication, whatever. But right now, look what we have with the current progress on AI and generative AI, and probably this is something that we can expect in the future with quantum. There are obviously some conventional problems, challenges for classical HPC and AI that we think, or we want, or we desire could be upgraded using quantum technology. For some of them, we have better evidences why it might work and what type of advantage we can expect them therefrom. For some of them, not at all. So we rather kind of bring them those applications in order to test and understand it better from more, let's say, from fundamental perspective, where this advantage we can expect from. This is the case of multiphysics simulations. This is the case of AI and generative modeling use case that they brought this time. But yeah, again, looking into the future, we think that the potential, let's say, of quantum technology and the complexity of the Hilbert space is not yet explored fully. And we want people surprise us with, let's say, their specific products and their specific, let's say, technology know-how that have not yet some practical applications within our industries, but can be matched to some very concrete physical problems that might arise in order to improve our products and our processes in the future. And so that we could integrate them somehow in the future as well. And I think when we launched this challenge, we were not sure if we will get at least any applications or submissions to that. So we said, like, okay, let's just do it and see. But we were also happy to see that maybe similarity in the thinking coming from Google, who also launched in parallel the biggest challenge or quest for searching for the best and the most native usage of the quantum technology, the most native quantum application.
Yeah, maybe I can compliment on that one, because I like this particular problem statement also very much, because in the end, of course, we have teams, and we use a lot of our time to investigate what are the key applications. And this is how we design it and how we define those problem statements. So this is why we were saying, okay, corrosion is a big problem, but we see potential. The same in logistics, the same in autonomy, the same in predictive modeling. But of course, we have with our capabilities always a kind of limits. So we cannot screen everything which is out there, and there are so many great ideas out. So the idea was really to be clear to the community. Maybe there's something out there which we just missed, and maybe we have one very cool solution and a potential application which is just not in on our mind, because we are coming from the existing challenges in our industry, and maybe there are some more things you can use, and you have some native applications which will be revealed in this kind of challenge. And I mean, I agree with Elvira. It's a kind of a risk. I mean, it's something very, very new, but we are really excited for all submissions, and also for this challenge to see what the community has maybe already thought about, and we are not aware.
So, as scientists, what are you particularly excited to see as a result? Is there a specific one of the tracks you're excited about, or are you looking for ideas in a certain space? Maybe that's a hint for people listening who want to apply, where you're kind of seeing that there could be an application or something exciting there.
Well, Anastasia, to tell honestly, that was quite a challenge just to formulate this goal enough, because I think we spent more time on just this one, because literally we had to write down that we want people to bring something, we don't know what, and to make it beautifully looking, but also that people understand the idea behind. So, of course, if we have some beautiful ideas, very innovative ideas, some completely outstanding ideas, not unimaginable ideas, we will be very excited and happy to see them and welcome them, and also to discuss through our businesses how they could be in future integrated through mutual collaborations. On my end, specifically, just because I'm coming from this background of solving differential equations, I would be very much excited to see some progress on the challenge of complex multiphysics simulations or aeroacoustic simulations. Again, this idea of digital twins, or like fully digital modeling to reduce the number of physical prototypes or physical tests that we do for aerodynamics, aeroacoustics, and whatever things, is quite interesting. It's quite beautiful, right? To move all those tests into the virtual space, make it very fast and efficient, and then bring the final product to production with, like, let's say, some minimal verification. We do have some limits on the physical side. There are some problems, or on the scale, for example, of a 3D dynamic for some complex multiphysics issues that we are not even able to tackle with a classical HPC or AI solutions. And that's why, obviously, we go with a hope to some different paradigms such as quantum. But on the quantum side, for instance, we haven't seen yet some, let's say, concrete ideas or some concrete evidences that the advantage might come from the quantum, and we don't even have those, let's say, 100% sure solvers. So it's not even the question of hardware progress, right? If tomorrow you give me like a perfect big quantum computer with enormous amount of qubits, I don't really know what to do with that just in order to solve my, for example, Navier-Stokes equation. So I would be very much excited to see if there is any potential in this area. Maybe, as Jasper mentioned, we need to be a little bit more, how to say, deeper, in the sense that not maybe solve the conventional equations, but go back to the physics of the problem and try to formulate it differently, which will be in a more quantum native way. So all those ideas I would love to see coming from the participants, in order to make it a little bit clear if there is something that might come from quantum in this area. I really hope so.
Yeah, I think maybe I can give you a rather a short statement. So from a scientific perspective, I mean, not of course from the company perspective, we are interested in the solution, in the technical validity of the solution, the scalability of the solution. I think when I think personally about the scientific perspective, I think it's about the novelty, right? So is there something coming? I'm sure there are many very cool ideas out, and there are many people who are maybe working in a closed niche, let's say in an academic group, or they have a startup but they don't have yet the visibility. And I think if we have these novel ideas, that's something, and this is something what I think from a scientific perspective would be a great outcome if we manage to bring this together, to provide a platform to those ideas, also to make this visible in the community. So that's why I mean, we formulated those problem statements, so all of them are really interesting for us. So I would try to avoid to say this one is more interesting than the other one, but for me it's like it's innovation. So this would be something I would probably say it's this novelty aspect.
Maybe you all should do a most outlandish innovative award for that challenge. Just be like, this is maybe 100 years in the future, but it's actually kind of interesting. Maybe we should actually take a look at that. And for folks who are thinking about applying to the challenge, you don't have to pick one of the fields. You can apply to multiple part of the application. So if you have one that's very near term, apply to that. And then if you have a crazy idea, maybe toss it into the ring as well. Why not?
And I also wanted to shout out our best partners in the world, the Quantum Insider first, because without them, we couldn't get that big exposure and to maybe reach out the very small, maybe labs or entities or people who are not scrolling every day through BMW or Airbus websites, to get information on this. So this was definitely the best decision ever that they had. And also AWS, at least for BMW Challenge, it's the second time in a row that we partnered together. They do amazing job, especially they were very kind to provide 3 credits for those people or entities who are not having, who don't have access to the actual quantum platforms, and but who have some very good ideas. So thanks so much to them, and I think this was also quite important in order to reach out like as many people as possible and to increase our chances to get as many good ideas as possible as well. So this can also be considered maybe as also an educational practice in some sense, because like people can train themselves or can do some development basically using those platforms that are available not only in the open source but also provided by the AWS, and train themselves as future specialists and engineers.
Yeah, you've mentioned this a little bit about, potential collaboration opportunities in the long term for people that participate in the challenges, the credits that are being provided as well. But how else are you planning on supporting the researchers who participate in this challenge in terms of resources, mentorship? Because a lot of people in the quantum space might be coming in without aviation or automotive experience, right?
So I think the idea is really to collaborate. So we have divided this challenge into different phases. We are now in the first phase. So the first phase is really to give the chance to the participants to write down their idea, and they will submit this by the end of the month. So we are super excited. Only a few days to go. And then we will select in the challenge team, so with BMW and the other partners, TQR, the Autonomy Insider, and AWS, we will select finalists for each use case and go into a second phase. In this second phase, we have the experts from our side, so from BMW, from Airbus, from AWS and the participants who will work together, and we will provide all the support we can to help them to implement their solution and to demonstrate this capability. So let's say this is it's really planned to have a very close mentorship in the second phase, because of course it's also in our interest to really bring as much value as possible to the proposals.
Well, thank you so much, Elvira and Jasper, for talking about this challenge with me and telling me more about what you all have been doing in the quantum space. So for everyone listening in on YouTube especially, if you go down in the description below, you can get a link to the Quantum Mobility Quest at qcc.thequantuminsider.com. Go there, register, and start working on these problems. Download the briefs. And if you have any questions, make sure to also do that in the comments below. We can definitely pass it on to the team. So make sure to apply. The deadline is coming up on April 30th, and we're excited to see your submissions.